learning objective we had yesterday, we're still in lesson 8.7, and the difference is today we're going to have to do estimating of the solution or rounding. So we're still going to solve a quadratic function using the square root method. So let's review from yesterday first, okay? We're not going to need a calculator for this one. We'll be all right. This is review from yesterday. So if I have this equation and I'm supposed to solve it, what would be my first move? What would be your first move? Isaac?
Take the square root of 3x plus 6 squared.
So we want to get the square root of 3x plus 6 squared. And if we take the square root of that side, we have to take the square root of the other side also. Okay? So what is the square root of 3x plus 6? That factor times itself.
3x plus 6.
3x plus 6. So 3x plus 6, and what is the square root of 9?
3.
Really?
It's
Positive and negative 3. There are two square roots of 9, positive and negative 3, and that's just our shortcut way of writing it. Okay, so now what would we have done next in yesterday's work? Cameron?
wrote an equation for both the negative and positive.
Okay, so the 3x plus 6, it says it can equal positive 3, and it says 3x plus 6 can equal negative 3. So go ahead and solve both of those because you're fully capable of doing that without my help. You have two equations to solve to get the solutions.
That's the first thing you wrote down.
You get the same solutions I do?
Yes.
Okay, so we have two solutions. So this tells us that, what are these solutions? Where would we find these on a graph again?
The x-axis.
Yeah, these are the points on the x-axis where the parabola crosses, where y is equal to 0. So we have found the two zeros of the function, which are also known as the two solutions. So if we actually foiled out that side and got that 9 moved over with it and tried to solve it by factoring, should we get the same thing? If it was factorable, should we get the same solution? Yes. What should happen if we graph it? Should we get the same solutions?
Yes.
So we have 3 ways we've learned how to solve these. Not all of them can be solved by all 3 ways, but just a little hint, this one could be. All 3 of them could, this one could be solved all 3 ways. Okay, so that's just reviewing what we did yesterday. And now we're still really going to do what we were doing yesterday, but we're just going to throw this little piece in there that says, you know what, not always do you have a perfect square. So if I asked you to take the square root of 6, what would you tell me it is?
It's not
About
perfect
2.5?
square.
Okay, how do you know it's about 2.5? One. Where'd you get
Because it's like 3 would be 9.
okay, the square root of 9 would be 3, okay. And
It's close to 6.
9 is close to 6, okay. What else is it close to on the other side?
2.
So 2 times 2, which is 4. So it's 6 is located, kind of sounds to me like you're trying to find which 2 perfect squares it's located between. So 6 is located between perfect square 4 and perfect square 9, and the perfect square root of 4 is
2.
2, and the square root of 9 is 3, so that means the square root of 6 has to be somewhere in between there, right? Has to be 2 something, 2 point something, or, so you said maybe about 2.5. Okay, well, that's why we're gonna have to round today, because we don't always have perfect square numbers that we're trying to find the square root of. We have other numbers on the number line that lie between some perfect squares, but they themselves are not perfect squares, so we have to estimate what they're going to be. Okay, but so we're going to still do the same process we did yesterday. We want x squared alone. What should we do first in this number 1? Brighton?
Divide by 6.
Divide both sides by 6. Okay, so we'll take 6x squared and divide it by 6. 36 divided by 6, and you're maybe, pretty soon going to recognize it seems like we just ruined it because 36 was a perfect square.
6.
But 36 divided by 6 is 6, and 6 is not a perfect square, is it? No. But we could not leave it as it was and take the square root even of the other side, because on the other side we had that 6 with our x squared, and over there it wasn't a perfect square any more than it is now on this side. So here's what we're going to do. We're still going to show that we are, to get x out of x squared, we're going to have to take the square root. But if we take the square root of that side, we have to take the square root of the other side. So now, when your calculator is going to come in handy, because we are not going to say about 2.5. We're going to put it into our calculator, and it says round to the nearest 100. Let's see if we can do that. So everybody figure out how to find the square root on your calculator. You're probably going to have a key like this, or you might have, no, I think this, everybody should have a key like this where they're able to put it in. And then I want you to tell me, we already have decided it's going to be 2 point something. So Malcolm, tell me, what does your calculator say when you take the square root of 6?
2.449489.
4, okay, you gotta slow down, you are way too fast for me. 4, 4,
94.
9, 4, 8, 9, 7, 4, 3. Okay. Well, this is what the calculator says, and by the way, it doesn't really stop here, it goes on forever. Because this is what we call an irrational number. Wait, would you put that, kind of in your hand? This is an irrational number. In other words, it will never end, it will never repeat, it just keeps going on and on and on like pi does. So we have to round it. So Brighton?
So if it was a round, or a number that repeats, would you stop at where it repeat and put a line over it?
You would if there was a repeating pattern. Let's say that it kind of looked like for a little bit here that maybe 4, 4, 9, maybe that was going to repeat, but then it didn't. But let's say 4, 4, 9 did repeat, then yes, we could put a line over those 3. If they didn't tell us to round, if they told us they wanted the exact answer, then yes, we could do that. But when you take the square root of, you need to hear me on this. When you take the square root of a non-square number, it will never repeat. It will never terminate, even though the calculator has to terminate it because it's got its window stops. It will never repeat. It will never terminate. It is just like that funny character called pi. It's an irrational number, so we always have to estimate it. We always have to round it just like we do with pi. We always have to work with an estimate of it. So which digit am I going to look at here to round with? Am I going to look at the
9.
The 9? It's in the thousands place, and I have to decide, is that 9 big enough to change this instead of being 44 hundredths? Should I change it to 45 hundredths?
Yes.
I should change it to 45 hundredths. So it's going to be 2. So here's how we're going to write this. I already wrote my equal sign. I have to erase it, and you need to erase yours too. Because we are rounding whenever we round. We put approximately equal to. We make the squiggly equal sign, showing that we had to round. And it is approximately 2 and 45 hundredths. But what else do we need? The plus or minus, yeah, the positive and the negative. There's still a positive and there's still a negative square root. a positive 2 45 hundredths and a negative 2 45 hundredths. They are both solutions. Right.
Can't you round it up even further if you so choose to?
If you're getting to make the choice, yes. So if you wanted to round it to the nearest 10, you could, if you get to make the choice. But did you get to make the choice? No. Okay, any other questions? Okay, then let's go try this next one. We have, what is the deal here? We have 144, take away 8x squared equals 0. Oh, well, considering this problem up here, that kind of looks like that one. What do you think we should do as our first move in this one that's going to actually save us one step if we make the right move? Ariel? Add 8x squared, that's right. Let's move the 8x squared over to the other side because nothing says which side it has to be on. It can be on the right side as easily as it can be on the left side. So now we're going to have 144 equals 8x squared. And again, you're going to be like, oh, 144, that's a perfect square. Yes. But there's this problem. It's not just x squared on the other side, it is 8x squared. So what do we have to do?
Divide by 8.
We have to divide both sides by 8. So we have to take that 144 and divide it by 8. We have to wreck it. And we have to take the 8x squared and divide it by 8. And now we're going to have x squared by itself over here. And what is 144 divided by 8?
18.
18.
Negative 18.
I don't think it's negative.
It's not?
Nothing in my calculator.
Better have a time with that calculator. Did you put 144 divided by 8? Okay, is 18 a perfect square?
No.
We're going to be rounding, aren't we? We're going to be estimating. So we're going to take the square root of both sides like we know we have to. Okay. So what is the square root of x squared? X. Are we going to be rounding? Yeah, we're going to be rounding, so we make our squiggly equal sign. And we're going to put square root of 18 into our calculators. Well, let's see, 18 lies between which two perfect squares? 9 and 16, or 16 and 25, or?
4 or 5. I mean 16.
It lies between 16 and 25, which means the square root should be somewhere between 4 and 5. So, just in case you can't trust your calculator, you at least want to maybe process that much. And then round to the nearest hundredth. Cameron, what is this rounded to the nearest hundredth?
4.24.
4.24. Positive or negative, right? Yeah. Okay. Do you want to try? Mrs. Krause, could you grab him a copy of the notes? Did you write the assignment down, sir? Okay. Any questions on these so far? Okay, let's go to the back side then. Number 3. 2x squared plus 11 equals 121. What should be our first move? Subtract 11. Okay, let's subtract 11. Now we have 2x squared equals what? 110. Okay. What's going to be our next move?
Probably divide by 2.
Divide by 2. Okay, so we'll take 2x squared, we'll divide it by 2. We'll take that 110, we'll divide it by 2. And then what will we do? What will we have?
55.
We're going to have x squared equals 55. Okay. 55. Oh, that must be a perfect square. It's a nice looking number. No?
No.
Well, before you put your fingers in your calculator, stop. What two perfect squares does 55 lie between? 60 is not a perfect square, but there is something in the 60s it is.
64.
64
49.
and 49. So that means if it lies between 49 and 64, 55 does, that means the square root of 49 is,
7 and 8.
and the square root of 64 is 8, so this, the square root of this has to be 7 point something, doesn't it?
Yes.
Okay, now let your calculator finish thinking for you. Oh, I already know this, don't I? Okay. Malcolm?
You want the wrong number first?
Nope, I just want it rounded to the nearest hundredth and then we'll.
7.42.
42? Okay, so 7 and 42 hundredths. Everybody agree with Malcolm? We like it? Okay, and there's our answers. There's our solutions. Now, tell me something. Do you think these would be good ones to solve by graphing?
No.
Why not?
Because they're going to be like inside the squares, they're not going to be on the lines.
Yeah, how are we going to approximate where this is crossing the x-axis? Brighton?
And since the number will go on forever, doesn't it? That kind of like make it an infinite possibility on in between those two numbers.
It makes it really hard to get exactly where it should be, you're right. It makes it really hard to get exactly where it should be on there. Even the graphing calculator, when the graphing calculator graphs it and shows the solutions, it is rounding where it is crossing the x-axis. So, okay, let's do Mr. Banks. Mr. Banks is building a retaining wall. You know what a retaining wall looks like? You all have a picture of this?
Kind of.
A retaining wall? Anybody know where there's some retaining walls around town?
The old ones?
Doesn't matter if they're old or they're new or,
Smith lumber.
huh? Trey? Or I'm sorry, Wanda, were you saying something?
Yeah, he was.
Smith Lumber has retaining walls?
Park and Rec, right outside the steps.
Yeah, Park and Rec has. How about those new flood walls they're putting up? Those are like retaining walls. And have you seen the new flood walls they're putting around town? Down by the college especially, and, okay, that's like a retaining wall. Okay, so Mr. Banks is building a retaining wall along one of the long sides of his rectangular garden. The garden is twice as long as it is wide. It has an area of 578 square feet. What will be the length of the retaining wall? So it appears we're solving for the length. Did they tell us what the width is?
No.
Okay, what did they tell us? Did they give us anything to help us out? Brighton?
It's twice as long as it's wide.
It's twice as long as it is wide. Well, that might be helpful information, okay? Isaac?
That's an area of 578 square feet.
Has an area of 578. Let's put that in here. I wonder if that's what I want there. 578. Huh. And Brighton said they also told us that it's twice as long as it is wide. So what could we call the width? The width, just the width.
Squared.
What?
Squared.
Where's 2x squared come from?
He said,
You just pull something out, you know,
he said like 2 times.
the width is, the length is twice the width. Well, what is the width?
We don't know.
Well, then what are we gonna call it?
X.
Oh, you will call it x? Okay.
Can we call it x squared?
Why?
Because it's times 2.
Well, we can call it x squared if you really want to, but boy, we're gonna make our lives pretty miserable if we do. So would you just trust me that x is gonna be a better choice? Yeah, you could do x squared though if you really want, but here's the deal. You're gonna see why it wouldn't work so well pretty soon here, or you're gonna be like, oh, I guess I better learn something else. Okay, so if the width is x, what would the length be?
Why?
Well, we could make it y, but do you really want 2 variables? Do you know how to solve an equation? One equation with 2 variables in it. I'll help you out. No, you don't. You know how to solve an equation with 2 variables in it as long as it's working with another equation in a system of equations. Well, we're not setting up 2 equations. We're only going to set up 1. The length is twice the width.
2. So this one would be 2x squared.
2.
No, x squared. It would be x squared.
2.
Because you said it would be 2.
Okay, let's just make up a width. What is this garden is 10 feet wide? Oh, what is length be?
20.
Oh, what'd you do?
That
Multiply 10 times
2.
2. It'd be 2x.
That's what I said the first.
Well, you keep changing your mind. How am I supposed to know what you want? The length is 2x, the width is x. The area is 578. How do we find the length area of a rectangle?
Multiply the length times width.
Length times width. That's how we find area. So now we'll substitute into our area formula. What are we going to put in for capital A?
578.
578. Oh, did I just hear x?
A little bit.
What are we going to put in for the length?
2x.
2x. What are we going to put in for the width?
X.
We just made it in our drawing there. Whoops. So now, what is 2x times x?
2x squared.
Thank goodness, we got that one down without much trouble. Okay.
Divide.
Now what will we do? Divide by
2.
2. 578 divided by 2. 2x squared divided by 2. So it's such a good thing we got those calculators today. 289
Equals x
equals x squared. And
plus or minus.
289, what do we do next?
Square root.
Square root each side. I know something about 289 that you don't know. What is it?
6.
It's a perfect square. And what is it, square
17.
root? 17. So a positive or negative 17, correct? And we can say equals because we didn't have to round, did we? Okay. Now, what was the original question?
How was the length?
What's the length? So what is the length of this garden?
17.
Or this retaining wall?
17.
17? Oh, really? You would pick that answer from a multiple choice bank and be happy with it? Are you kidding me? Check. It's wrong.
Y'all better get us.
Did they ask for the width?
No.
Is that what we just found?
Don't worry about length.
X is...
Length.
No, X is...
There
Length. Width.
We just found the width. And you're going to be, oh, trust me, they're going to put that answer in the answer bank. They're going to be like, oh, these guys, and they're going to make it answer A. Because they know, as soon as you see answer A, 17 feet, you're going to be like, yes, I got it. When really they were asking you for the what? The length. Oh, golly. So we're going to have to go over here and say length is 2x. So I'm not going to be happy to say 17 is the length. I'm going to do what? I'm going to do what?
Multiply 17 by 2.
Absolutely. 2 times 17. And then there's going to be this other choice. It's going to be answer D in the answer bank, and it's going to be what? 34, and that's the one you should have chosen. And it's 34 what, by the way? If the area was in square feet, then what are the dimensions measured in?
Cubic.
Okay, let's not go anywhere else we shouldn't. If the area is measured in square feet, please show me that part of your brain that is firm and working today. The dimensions have to be what? Measured in feet. Because to get square feet, you take feet times feet. Length times width. So the width is measured in feet, the length is measured in feet, feet times feet is square feet per area. You need to know this. Why can't we just spell that out like nothing? The length has to be measured in feet, not, since when? If I asked you to measure the length of this room, would you get out a square and see how many squares it was to get from one end to the other? That isn't what you would do, would you? No. So it's 34 feet. And you know what, one of the other multiple choice answers in the answer bank might be 34 square feet. Just to check you all out, see if you even know what the label should be. They know what kind of mistakes you're gonna make, and you guys are just acting like, you're gonna be juniors next year, and you're gonna be taking the ACT test. And they're gonna have multiple choice, and you're gonna be so excited that you got an answer.
Yeah, that's what I heard.
And then when you get that answer, and then you get, you're feeling really good, you walk away from this test, and then your ACT report comes back, and in math, you scored a 16. Guess what the highest is you can score in it? 35. Yeah, seriously. So, you know what? Don't take this lightly. We need to think, not just do. We also need to think, okay?